Welcome to Beyond Tech Hype, where we strip away the buzzwords, challenge the myths, and dive into the real science shaping our world. Remember the periodic table from high school? The chart your chemistry teacher swore you'd thank them for later? Well, today is that later. Because buried in that sea of symbols, down in the rows hardly anyone memorized, lie the rare earth elements. These aren't the celebrity elements like gold or silver. They're more like the quiet geniuses working backstage, unseen but absolutely essential to the show called Modern Life. Despite the name, rare earths aren't really rare. They're a group of 17 metallic elements, including the 15 lanthanides plus scandium and yttrium. They're scattered across the planet's crust, but rarely found in concentrated deposits. Think of them as spices in a massive stew, everywhere but in tiny amounts. Their names, neodymium, dysprosium, terbium, europium, sound more like alien planets than metals, yet they power nearly everything with a circuit or a motor. Chemically, rare earths share unique electron structures that make them magnetic, luminescent, and exceptionally good at conducting heat. They're the Swiss Army knives of materials science. The modern world runs on performance, efficiency, and miniaturization, three things that rare earths enable better than anything else. Neodymium and samarium make the world's strongest permanent magnets, found in electric vehicles, wind turbines, and hard drives. Europium and terbium give vivid color to phone screens and LEDs. Lanthanum refines oil into gasoline. Cerium helps keep catalytic converters clean. Yttrium and gadolinium power MRI scanners and superconductors. So next time you swipe your smartphone or start your hybrid car, remember, it's not just lithium and silicon doing the work. Rare earths are the quiet MVPs behind the curtain. Extracting rare earths isn't easy. They're often trapped within ordinary rock, mixed with other minerals that refuse to separate politely. Mining them is like trying to pick out a specific noodle from a bowl of spaghetti with chopsticks. Once mined, the ores go through complex chemical separation involving acids, solvents, and countless washing stages. It's a slow, costly process that requires precision, and unfortunately, it can create waste if not managed responsibly. The challenge isn't scarcity of the metals themselves, it's the difficulty and expense of refining them cleanly and efficiently. That's why even countries with large reserves still import refined materials from specialized producers. Take a look around you right now. There's a 99% chance you're within arm's reach of a device that depends on rare earths. Your laptop fan? Magnetized by neodymium. Your earbuds? Mini speakers powered by dysprosium. That energy-saving bulb above you? It glows thanks to europium and terbium. And if you drive an EV, congratulations! You're literally sitting on a rolling museum of rare earth technology. They're in satellites, fighter jets, laser guidance systems, wind farms, and even in the polishing powder used to make smartphone glass crystal clear. In short, they're everywhere, hiding in plain sight. Here's the funny part. Most of us thought we left the periodic table behind after school. Now, the same table is driving the next industrial era. It's almost poetic. Chemistry getting the last laugh. Those strange names we ignored in class? They're now worth billions of dollars and form the foundation of global innovation. If high school you ever asked, "When will I use this in real life?" Well, you're probably holding the answer right now in the form of your phone. Rare earths are the backbone of progress because they make technology perform. They don't just exist in small amounts, they transform how machines behave. Without neodymium magnets, wind turbines would be twice the size and half as efficient. Without yttrium, LED lights would flicker and fade. Without cerium, exhaust systems would choke on pollutants. They enable lighter engines, sharper imaging, cleaner energy, faster data, the building blocks of every modern ambition. It's as if civilization decided to build a symphony, and rare earths became the instruments no one sees, yet everyone hears. The next frontier isn't about digging deeper, it's about recycling smarter and engineering alternatives. Researchers are developing methods to recover rare earths from electronic waste, extracting valuable metals from discarded phones and motors. It's called urban mining. At the same time, scientists are designing new materials that mimic rare earth properties using abundant elements like iron and nitrogen. The goal isn't to replace rare earths entirely, it's to use them more efficiently. Imagine a future where we close the loop, from mining to manufacturing to recovery, a truly circular ecosystem of technology. Rare earths remind us that innovation doesn't always mean discovering something new. Sometimes it's about rediscovering what was already there, hiding in the periodic table, waiting for the world to catch up. They represent the invisible thread connecting physics, chemistry, engineering, and sustainability. The unseen foundation beneath every bright screen, quiet motor, and precise satellite orbit. In a way, rare earths are humanity's most ironic treasure, common in the Earth's crust, yet priceless in human progress. If modern civilization had bones, rare earths would be the spine, holding everything upright, flexible, and connected. We don't often think about them, just like we don't think about oxygen or gravity, yet without them, the whole system collapses. So the next time someone mentions the tech revolution, remember, it's powered not just by software and silicon, but by the forgotten elements of chemistry class, the quiet heroes from the lower rows of the periodic table. You've been watching Beyond Tech Hype, where we uncover the science that makes our modern world tick. If you enjoyed this dive into the unseen elements shaping technology, hit subscribe, give a like, and share this video. Until next time, stay curious, stay grounded, and never stop asking what's beyond the hype.